All right, for problem number 3, we've got an interesting situation where we are going, um, we're accelerating at 2 meters per second, and then we reach a certain speed, and then we slow down at a constant rate, and we stop, and we want to know how much time elapses and how far the vehicle travels. That's problem number 3. So what I'm going to begin to do is actually draw out the situation. So I'm going to talk about a beginning part of the trip and an end part of the trip. And I'm going to split this problem into 2 parts. So I'm going to have an initial position of 0, an initial speed or velocity of 0. And I have an acceleration for this part, which is 2 meters per second squared. And I'm told that I have a final speed of 20 meters per second. And then what happens is that my acceleration goes in reverse. And you know what? I'm actually going to do this in so I have a speed here of 20 meters per second. And now what I'm going to do is I'm going to go ahead and switch colors because I want to do the second part in different colors. So the initial velocity for the second part is 20 meters per second. I have a negative acceleration of 1 meter per second squared. Negative because it's going reverse of the direction that the train's moving. I will actually call this new initial position 0, and this final position will be unknown. And of course, the distance I travel here is unknown. My time covered is unknown. I don't know how much time I'm covering here in the second part either. So let's just kind of set up the first part of the equation and solve for unknowns. So I will begin by blindly stabbing at formulas. I'm not even making that up. That sounds so pessimistic, but this is the truth. I've drawn the situation. I've labeled the letters. So really it's just a question of plugging in numbers to figure out what's going on. So x is 1/2 times 2 times unknown t squared plus 0 times 2. Sorry, 0 times t plus 0. So that formula is not helpful. Let's try the next formula. V equals AT plus V naught. And let's see what we can get. So I know that my final speed is 20, A is 2, T is unknown, and my initial speed is 0. So I know that T actually ends up being 10 seconds to accelerate to speed. So there's one helpful piece of information. Now, can I do anything with that? Well, let's just try the third formula just to see if we can solve something with that. So we have V squared equals V naught squared plus 2A x minus x naught. We know that V final is 20, so we'll square that, equals 0 squared plus 2 times 2 plus the unknown x minus 0. So we're going to end up getting 400 divided by 4 equals x. So it seems that my final position for accelerating in a positive direction is 100 meters. So it seems I've covered 100 meters of distance right here. Awesome. Now let's go to the next part of this problem and do a similar process. So we'll start with x equals 1/2 AT squared plus V naught t plus x naught. X is unknown, 1/2 times an acceleration of -1 times an unknown time plus 20 times time plus 0. This one's just awful. All right, let's try the next formula. V equals AT plus V naught. Let's see how much time that takes. So we have a final speed of 0 equals -1 times the time plus an initial speed of 20 meters per second going forward. So when I solve for time there, it's going to take me 20 seconds to come to a stop. Now let's go ahead and try this formula. V squared is V naught squared plus 2AX minus x naught. We'll continue here. So 0 equals 20 squared plus 2 times -1 plus x minus 0. And when we actually solve here, we're going to end up getting this x is 200 meters. So let's kind of be careful. I've got 200 meters, so I've got here 200 meters covered here. I've got 100 meters covered here. So let's be clear. Total distance is 300 meters because that's 200 plus 100. And the total time is 30 seconds, adding 20 seconds plus 10 seconds. All right, so that's it for problem number 3.